Good morning. This is Mr. McMurray, and it's a beautiful Wednesday morning. There we go. I knew I could pull it out, and I assume it is. It's too dark to tell for sure right now, but I'm sure it will be. Felt good anyhow. So here we go. We're going to do this worksheet today. We may extend it through tomorrow, or I may have a quiz tomorrow. We're kind of still debating that one, but we'll see. Okay, I'll let you know. Yeah, just check the canvas and it'll tell you. But then, this is elastic and elastic collisions worksheet, and we're talking about collisions. We talked about our notes that whether you have an elastic collision or an inelastic collision, you will always have a same amount of momentum before and the same amount after. All right. Now, in this case, we have a passenger car on a train and a flat car, which is usually used to haul freight, and they're colliding, and this one's going this direction, this one's going that direction. Okay, now, the first thing we need to remember is that one of these is a negative because they're going in opposite directions. Okay, not one direction. That would be a musical group, but all right. So we're going to say this one's negative and this one's positive, okay? Now you could do it the other way around. It doesn't matter as long as you remember which direction you said negative, because if you get a negative number, that means it's going that direction. Okay, if you get a positive number, it should be going whatever direction you said was positive. But generally speaking, we just say to the right is positive, left is negative. All right. Anyhow, so these two hit. After they hit, they continue to go to the right. Okay, so let's go through our questions here. First of all, it says, what type of a collision is depicted here? Well, they hit and they stick together. So that is exactly. Glad you got that one. All right. That is an inelastic collision. All right. How do we know that? Well, because they stick together. If they had bounced apart or were not still touching, then they would not have been it would have been elastic, but that's not what happened here. All right. Now, the next question is, if we're going to set up this formula, we need to find out the momentum of both of them, okay? And we know the formula for momentum. Now, the only difference is when we have two vehicles, we're going to say M1, that's going to be the mass of the first vehicle, and then velocity, initial velocity 1, and that's going to be the velocity of the first vehicle. All right, plus the mass of the second vehicle, okay, so forth. Okay, so this is finding the momentum of each of them. Now we need to find them before and we need to find them after, okay? So here's the deal. The initial momentum, if we're going to do that, click in our formula here, that is going to be M1 times V1, and the passenger car is 10 kilograms, okay, times the velocity of initial velocity, which is 3.50. And we will do sig digs on this, so make sure you do that. All right, 3.50 meters per second. All right, so there we go. It's 10 kilograms times 3.5 meters per second. All right, and when you get that answer, then that would go down here. Now, just being able to look at that, I'm going to guess that's going to be 35.0 kilograms times meters per second. All right, like so. Crazy math skills, especially when you multiply things by 10. All right, so that's the initial momentum of the passenger car. Now we need to know the initial momentum of the flat car. Okay, and so if we do this, we know that the mass of the flat car was 7.50 kilograms, so we put 7.50 kilograms times the initial velocity of it. Okay, and originally it was going 2.20 meters per second. To the left, though. So since it's going to the left, remember we said it is, up here we had said that it is a negative velocity. So there we go. All right, so when you type that up, then you would click it, you get your answer, and it comes out to negative 16.5. Oops, whoa. Hang on, what happened here? Okay, let me try this again. All right, negative 16.5 kilograms times meters per second. All right, there we go. Okay, so far there we go. We've got the initial one. Now, the last question says, what is the final velocity of the two cars? Well, basically, if we take this formula here, we have this is the momentum from the beginning. You had this plus this equals the momentum afterwards. Okay, but notice instead of doing them separately, we can combine these because now they're stuck together. So the mass is really the mass of the passenger car plus the mass of the flat car, and they're going to be going the same final velocity. So we can add this to that, and we get 17.5. All right. Because when we add things together, we go by the decimal places. There's 1 here and there's 2 there. So we're going to have the least number. So we have 1 decimal place in our answer. So we add 10.0 times 7.50 and we get 17.5. And that is kilograms times the final velocity, which we do not know what that is. That's what we're trying to find. All right. So if we plug in the numbers we have over here, we have 35 plus a negative 16.5 there we go. All right, and whatever we get when we subtract those two are going to be kilograms times meters per second is equal to 17.5 kilograms times the final velocity. All right, then we would divide both sides by 17.5, so you would add these two together, you get about 18.5, so you end up with 18.5 divided by 17.5, which gives you, we need 3 sig digs in our answer, so that's going to be equal to, whoops, not negative, there we go, equals 1.06 meters per second. All right. As the kilograms here would cancel with the kilograms there, and that would just leave our answer with meters per second. All right, so that tells us the final velocity is going to be 1.06 meters per second. All right, now the other thing it asks you is, what is the final momentum of the coupled cars? Well, we know that's equal to 17 kilograms times the final velocity. Now we know what the final velocity is, so we stick that in there. And when you multiply that, you can put that answer right here. Don't forget to do that because there needs to be another answer there, okay? So tell me what the final momentum would be, and with the proper number of sig digs. All right, okay, now that's an inelastic. So naturally, of course, we're going to give you an elastic one, all right, just so we can do one of each. All right, so you have 2 train cars of identical mass, all right? The mass is equal to 12 kilograms, so they're both 12 kilograms. We know that for both of them, all right? After they hit, they collide, they hit, they move, and then A moves back to the left and B moves to the right, okay? It says car A was initially traveling at 2.0 meters per second squared. You might want to write that down there. I'm not going to right now because it takes me a while with the pen. And car B was initially traveling 3.0 meters to the left. Now, since it's going to the left, that's right, it's going to be a negative 3.0 meters per second to the left. All right. Now, let's answer our questions. First thing, what type of collision? Well, they bounced apart, so we know that this is an elastic. Is it a perfectly elastic collision? Probably not, but this is the real world. In the real world, you don't usually have perfectly elastic collisions except for on the molecular or atomic level, and we're not on that. These are obviously bigger than an atom, so that's not the deal. All right, so elastic collision. Now, second thing is, what is the initial momentum of car B? Well, we know it was 12.0 kilograms times its mass, and car going to the right was 2.0 meters per second. All right, multiply that, we know the answer should be 24 kilograms times meters per second. All right. And actually, that's correct, it's 24 because we have 2 sig digs here, 2.0, so we only have to have 2 sig digs there. All right, now we go down to the next one. What was the initial momentum of car B? All right, now car B was going to be 12 kilograms again. 12 kilograms times its speed, which is 3.0 meters per second. All right, but it's going to the left. Whoops. First of all, that's not O, that was a O. And it is negative because it's going to the left. So if we multiply that, we know we're going to have 36. Oops, excuse me. Pardon my error there. Negative 36 kilograms times meters per second. All right. And there we go. Now, it wants to know the final momentum of car A. Well, that's interesting. We need to know that, don't we? And we need to know what the final car of velocity of car B is and what is its final momentum. All right. Well, here we go. We do know car A is traveling after the collision at a velocity of 12.5 meters per second to the left. So if we put that here, we know that's going to be still 12.0 kilograms times its new velocity, which is 2.5 meters per second. But once again, it's going to the left now. So we know that it's going to be a negative. All right. And if we multiply that, I believe you will get negative 30 kilograms times meters per second. Now, technically, that's not 2 sig digs, so the best answer would be, if you made that, negative 3.0 times 10 to the more first power kilograms times meters per second. All right, so this would be the best answer there, because then you would have, oops, change that real quick. All right, 10 to the first kilograms times meters per second. All right. All right, so if we plug those answers in here, we got 24. Okay, I'm gonna write the units because I don't want to run out of time here. Okay, this one's going to be negative 36. All right, equals the momentum of car A, which we know is negative 30. I'm just going to write it as negative 30 here. Okay, plus, here we go, plus the this one, which we know is 12.0 kilograms times the final velocity of car B. Okay, so first of all, we can add these two together and we get negative 12. Okay, so negative 12, okay, is equal to negative 30 plus 12.0 kilograms times, I'm just going to put V. All right. Okay, now to get rid of this one, since it's added to that, we need to do the opposite. Okay, so anyhow, this is negative 30, so to do the opposite of that, we need to add 30 to both sides. If we add 30 to both sides, 30 plus 12 gives you 18. Okay. And it would cancel this one out. So we have 18 is equal to 12 kilograms times the final velocity. All right, we divide both sides by 12. 18 divided by 12 gives you 1.5 meters per second, and we use that as positive, and it's going to the right, so it should be positive, so that means we got the sign right. Now, the last thing you need to do is find the momentum. You would do 12 times 1.5, and you would get 18. Because we know the final velocity is 1.5 multiplied by 12, you get 18 kilograms times meters per second. All right. Okay, that is it. If you will go ahead and finish that, and hopefully if I don't see you again before then, have a good Thanksgiving. I may have the quiz tomorrow.